Hello once again, kiddos. Today we're going to be studying Newton's third law of motion and learn to calculate speed. First of all, we're going to watch a short video about Newton's third law of motion. Please make sure as we go through this video, you're reading what is on the screen and the captions throughout the short film. So for Newton's third law, it states for every action there is an equal and opposite reaction. This is Newton's most famous law. You'll often hear parents say that for everything that you do, there's a consequence, whether good or bad, or something like that. Sometimes you may hear teachers say it. I know I say it sometimes. If you study, the equal and opposite reaction is you're going to make a better grade. Whereas if you don't study, then the equal and opposite reaction is a lesser grade. So in this example, I want you to look at our rocket. I want you to identify the action. The action is that the rocket's gases go toward the ground. Identify the reaction. The gases push against the ground, so the rocket then moves up. So the action is the thrust of the rocket. The reaction is the movement of the rocket flying straight up in the air. Make sure that you are filling in your blanks. This should be in your teacher-made packet. Please remember to pause at any time that you need additional time. So page 8 of the teacher packet, we are going to complete writing the third law as soon as Ms. Fleming makes it so that it is not a mess. I am not sure what happened to it other than a newer version of it, and it has made it so that it's messed up. So there you go. Newton's third law: for every action, there is an equal and opposite reaction. And it always operates in pairs. All right, remember to pause as you need. Now please, in your LearnEd notebook, turn to bell ringer 19. This is on page 5. On a distance time graph, which axis represents distance? You may not know this. We will be going over it very soon. So the y-axis will represent distance. And I hope no one said z-axis since we studied this in math. And then bell ringer number 20. On a distance time graph, which axis represents time? I hope you said the x-axis. So now we have completed our talk about the third law of motion. It is just that every action has an equal and opposite reaction. So now let's focus on calculating the speed of an object. So vocabulary is a very important part of learning science. Let's begin by reviewing some of the key words. And you're going to do this by clicking on the link provided for you and going to eWord Games. The directions are in your packet. So you want to go to eWord Games. You can do the others on this as well, but chapter 19 here is what focuses on motion, gravity, and work, and what we're studying at this time. So now please turn to the word web for speed and write down the rate at which an object changes position. So for just a moment, I would like for you to think about what is speed? How would you define speed in your own words? How would you describe speed to someone that was much younger than you? Some of you may say it's a measure of how fast we go. Some of you may say that it's a measure of how far we go and how long it takes to get there. I really wish I could hear what you had to say about it. I know some of you would have some really great thoughts. So let's look at the rate at which an object moves is its speed. Speed can be calculated this way. You must write this down. You must know this. You must know this for next year, for the testing. at the end of this unit, you need to know this for life, because when you're going 60 miles an hour, that literally means it's going to take you 1 hour to travel 60 miles. Whereas if you are going on a trip that's 60 miles away, but you're only able to travel 30 miles an hour because maybe you're hauling a heavy load, then it's going to take you 2 hours to get there. So speed equals distance divided by time. So let's say that the distance is 300 kilometers. The time is 5 hours. So you would take and do 300 divided by 5, and that would equal 60 kilometers an hour. I'm sorry it's so sloppy. Now, on the next couple pages, you have some problems to work out. I would like to see you do those on your own. You have a problem about a wasp. And then you have speed practice problems. So you may pause the video and answer those problems. The problem says a wasp is flying towards you at 8 meters a second. You are stunned and cannot move. It takes 2 seconds for the wasp to sting you. How far did the wasp travel? So what do we know? We know the wasp is flying at 8 meters a second, and it took 2 seconds for the wasp to sting me. What do you need to know? You need to know the distance and time, and then the equation, speed equals distance divided by time. So when we make our substitution, we have 8 over 2. And so 8 divided by 2 equals 4 meters a second. Our next page says speed practice problems. The train travels 183 miles. It took 3 hours to reach its destination. What was the train's speed? So you would have 183 divided by 3. And so when you solve that, you should get 61 miles an hour. And then on number 2, it says in 6 seconds, Jack ran 36 meters. How fast was Jack running? So we have to take the distance, which is 36 meters, and we're going to divide it by 6, which is the time, and then it shows that he is running 6 meters a second. So why is it necessary to measure speed in real life? In real life, we may need to see if we are getting faster at something. We may want to see if an object is faster than something else. For driving purposes, for travel. There are many different reasons why we may do this. So now you try it. I'll pause the video. I want you to read the problem, solve it, and then we'll show the answer. Please make sure you're pausing the video when I ask you to, so that you can solve certain tasks. So now let's check out our answer. Student A traveled 10 kilometers an hour. Student B traveled 10 kilometers an hour. So both students traveled at the same speed. This is the end of video 1. There will be an additional video. Make sure you watch part 2.